Welcome to lab number 6, module 1. Lab number 6, module 1. So let me write it down here, lab 6. And the idea is to build a VxLAN EVPN BGP fabric with asymmetric IRB. So the different pieces for this topology, I guess before I start going over the different components of this EVPN BGP fabric creation, there is some context that I have to provide. So let's go ahead and for leaf 1, let's build let's do a building here. Let's say this is location A. So let's go ahead and build our building here, and let's call it location A. And then the one for leaf 2 is going to be location B, for example. So let's go ahead and create another building. Let's call it location B. Okay, so that's good. So now that we have these two locations, let's say that the spines reside in a different building. Let's call this location main data center, for example. Main data center. And the multifunction switches that can do layer 2, layer 3 for the location main, spine 1 and spine 2, are going to be members of the autonomous system 65022. And for location A, this leaf 1 is going to be part of the autonomous system 65021, for example. And for location B, leaf 2, the autonomous is going to belong also to autonomous system 65021. So those are the basic components so far. Now that I have identified the three locations and the purpose of each leaf and the purpose of each spine, the idea of this lab is to be able to, if you look here on the bottom left, to have VLAN 2. The idea is to have VLAN 102 from location A stretched over layer 3 all the way to location 2. So basically creating a system that will allow us to send layer 2 packets over a layer 3 network using overlay tunnels such as the red line that you see here and the purple line that you see as well. So those are two different VLANs. One, like for example, if we stick to VLAN 102, VLAN 102 is going to be related to this VNI purple, VNI 1002. And let's draw a different line for VLAN 104. So let's see if we can use red here. So this is VLAN 104. Let's say that we want to stretch VLAN 104 over layer 3. Let's say that, yeah, don't pay attention to the IP addresses. just pay attention to the VLAN 104. And so basically, VLAN 104 is going to be tied to VNI 1004. And the principle is super simple. The principle is super simple. And right now, the way it's set up, it's not going to work because I haven't configured or show you that BGP need to be enabled, and I haven't talked about the EVPN process to be enabled. So far, I have pointed out that the goal is to stretch that VLAN 102 over layer 3 from location A to location B. So far, that's what I have laid out on this scenario. So imagine that you are in VLAN 102. Let's say that this is a a subway, and the subway station is BTAP 1. So this is the subway station in which you're gonna go into, right? So that way you can catch the subway. In this subway, the idea for you is to take the red line, not the red line. Let's go back here and stay. Okay, so VLAN 102, which is going to be the purple. So what I need to do here is go into the station and buy a ticket to get into the purple line, in which I need to catch the subway from the purple line. That will take me all the way to station 2, in this case the BTAP 2. And once I reach BTAP 2, the whole idea is to go into let's say VLAN 102, and then once I get once I get out into the station, then I'm gonna look for the exit. Oh, okay, I need to go to VLAN 102, so I'm gonna take the exit Ethernet 111, and then okay, so now I'm gonna be able to arrive to my destination, which is the street address 192.168.102.11. I mean the address for the building I wanna go into. So now I made the whole travel from this address right here. I went into the VTAP station. I got into the subway. I took the purple line. I went all the cross on VNI 102, which is related to VLAN 102. And then once I reach out the station BTAP 2, I look at the instructions and say, okay, if you want to go to this address, which is 192.168.102.11, you need to exit Ethernet 111. And then I go my merry way, and then I arrive to my destination. And I don't know why I changed colors. I'm supposed to be the same guy. All right. So now for the second scenario, it's going to be the let's say that my friend Keith, need to go to he's in this VLAN 104, but he wants to go to VLAN 104 on location B. And the address is different, right? It's gonna be this is gonna be the other network, right? The other address 192.168.104, right? 11. That's the whole address for this location. So Keith going to the BTAP 1 and say, hey, I want to go to 192.168.104.11. How do I get there? So then on the BTAP 1 is gonna say, well, you need to take the red line, because VLAN 104 is related to 1004. So then Keith going to this other subway train, and once arrives at BTAP number 2, Keith is gonna say, oh, I need to go to this address 192.168.104.11. What do I do? And then the instructions are gonna tell him, hey, go to Ethernet 114, and then you can go in your merry way and arrive at your destination. So that's the whole idea, to be able to accomplish this. But in order to create these tunnels, in order to create these subways, there is a few components that have to be activated, that has to be configured in order to create these tunnels. So I'm going to start laid out one by one, okay? So the first component that has to be established is going to be that in leaf 1 is where we're going to have the layer 3 layer 2 boundary. So let's call this boundary. In leaf 2 we're going to have a layer 3 layer 2 boundary, right? Layer 2 to provide layer 2 adjacency for downstream devices such as servers, PCs, APs, anything that has to do with IP addressing, storage, for example. So in order to allow location 1 layer 3 communication with the spines and the leaves, the BGP protocol needs to be enabled in order to for all these multifunction switches that can do layer 2 layer 3 to exchange routes. So I'm gonna see if I can do with bold letters one of the components that had to be present to create this VxLAN EVPN BGP fabric. So this BGP that I'm drawing here is going to take care of the underlay network. The underlay network that is going to establish the neighbor relationship between all these 4 multifunction switches. And we're going to have to enter each of their interfaces into the BGP process, just like the previous video about BGP, creating a layer 3 BGP fabric, for example. Another thing that has to be activated is the EVPN process. So let's go ahead and write EVPN. So the EVPN protocol, what it's going to do for us is that it's going to provide the ability for us to create these virtual tunnels, and in each virtual tunnel, as you can see, you can have like you remember the subway train for the red line and the subway train for the purple line. So that EVPN process will allow us to establish these BTAPs that I was telling you about, and those BTAPs will serve to take a layer 2 frame, bundle into a layer 3 frame that has to go to destination location 2 or location B, whether it's VLAN 102 or VLAN 104. Once it gets into the BTAP, it gets encapsulated into a VxLAN packet, and then that VxLAN, imagine that you are inside that VxLAN subway train. Let's say you're on the purple line, and that VxLAN train is gonna travel to VTAP 2, and once that VxLAN frame gets into VTAP 2, it's gonna be decapsulated, meaning that you exit that train, and then you can walk out via Ethernet 111 and into your destination. So that's the whole travel, and EVPN will enable that. So EVPN, what it's going to do also, let me use the green color. It's going to create a virtual, let me draw it here with green, a virtual control plane. That is going to have the information of all the routes connected into the BGP into the BGP process for these overlaid networks, right? Because remember, BGP for the underlay is one thing, and BGP for the overlay. That's another configuration that we're going to be doing to enable the routing of these overlay tunnels, so that way you can communicate between 104 and 102 if necessary. So that EVPN control plane, which is a software, right, control plane, is going to allow us to have information about VTAP 1 and all the hosts and all the routes it knows. And then let's say that you have VTAP 2, it's going to know everything if you want to share, right, with the rest of the multifunction routers. So that way, whenever Keith want to go to VLAN 104 in location B, for example, then it knows that you need to go into the red line in order to get to this other address, because the EVPN process has that information on the database that it sends out to all the VTAPs. So it kind of share that information with all the VTAPs, and that's how we're able to send layer 2 over layer 3 and being able to extend the VLANs from location A to location B. So let me draw here the VxLAN protocol. That's what is going to enable. Remember what I said, the VxLAN subway train, right? That's where the layer 2 packet is encapsulated, and then once you arrive to VTAP 2, you get decapsulated, and then you have a layer 3 and then a layer 2 to your final destination. That is a lot of information, but that is the context of the lab, so that way you can see all the different pieces of this solution. There is a whole lot more that has to be talked about, but I just want to keep it simple. If I were to recap, let's use Orange. So the first thing I'm going to be doing here is going to make sure that we have VLAN 102, VLAN 104, in leaf 1, that we establish the layer 2, layer 3 boundary, that we enable the BGP routing protocol for the underlay, so that way VTAP 1 can establish a neighbor relationship with spine 1. VTAP, not VTAP. So router leaf 1 establish a relationship with the spine 1. Router 1 in leaf 1 establish a neighbor relationship with the spine 2. That you do establish neighbor relationship between leaf 2 and spine 1, leaf 2 and spine 2, and then from spine 1 establish neighbor relationship with leaf 1 and with leaf 2, and then spine 1 establishing neighbor relationship with leaf 1 and leaf 2. And once you establish all those relationships, that's going to take care of the underlay piece. The next step, I'm going to use, this is getting busy. I'm going to use the highlighter. The next step is to turn on the EVPN process. We're going to enable BGP for the overlay, and the EVPN is going to create us this control plane I was telling you about. And this control plane is going to have each of the VTAP routes that it knows. If you allow to learn the routes attached connected to this VTAP 1, for example, and any other route that is associated with, so that way this EVPN process have the database that can be distributed between VTAPs, and that way if you need to go from host 1 to host 4, it knows where to which VTAP it needs to travel, so that way you can reach your destination like Kit did and I did. I guess I'm gonna stop on this one. I wish I can make it a little bit more clear, but I guess once you start seeing the lab, that's going to be part 2. And I think I'm going to have a part 3 because I don't want the lab to go too long. And so part 2 is going to be just verification to make sure that all the commands, all the statements are on each of the leaves. And then I think what I'm going to do for the third video on this lab 6 is going to be about the verification and to make sure that the setup is working. With that said, this is lab number 6 is going to be a 3-part, and I hope you enjoy it. Please leave your comments if you think this is helpful.